This video is going to be focused primarily on pointers. However, I'm going to kind of give a brief example because I'm going to be covering how, just on a very high level, how memory is going to be working, because that's kind of something that you don't necessarily need to understand, but it's a good way to visualize it in your head to see, okay, here's how pointers work. Here's how pass by reference works. Here's how pass by copy works, and kind of different ways that they can be used and where you can achieve a benefit by using one of those three. So you can kind of think, okay, if you understand it, you can easily think to yourself, hey, it would probably be better to use blank for this situation. Now, what I'm going to do is I'm just going to create a very simple class because I'm going to use a class object just as the example. So class person, I'm going to do public. I'm just going to have int age equals 30 and string name equals, I don't know, Bob. So that's all it's going to contain. So what I want to do is I want to go ahead and create a class object just like normal. So person, or keeping on, I'm going to name it a person, and that's it. So if I print out the stuff, so let me go ahead and see out age, and let me go ahead and do name as well. And I'll go ahead and end the line. So if I print this out, age 30, name Bob, like so. Now I want to create a function to change these. So void change age and name. And I want to make it take in a person. So all I'm going to do is I'm just going to simply add 5 to age. So person.age plus equals 5. And then I'm going to do, let's see, put it in here. Name dot, not append, right? Oh, I'm being stupid. Person name dot append. Let's do Bob Marley. Oh no, that comes to mind. And let me run it again. Well, actually, I forgot to call the function. So I'm going to go ahead and call the function first. So change age and name. And I'm going to pass in our person object that we just created. As you can see, it didn't actually change anything to person here. That's because we're pretty much doing pass by copy. So this a person right here is essentially a new object of a person. Now here's where you get into pointers. So before I even explain anything, let me convert this over to a pointer. So with pointers, you obviously have to change the operator to access what you need, like so. And let me go ahead and run it. All right, what did I mess up on? Person? Oh, right. Okay. I'll explain what I did here in a minute. So now when you look at it, well, the only thing we changed was changed our object to a pointer. But now we added 5 to the age, so instead of being 30, it's now 35. And for the name, instead of just being Bob, it's Bob Marley. Now, why is that when before it did nothing? So before it was just its own object. It didn't actually take in this person right here. So I drew this up. Because apparently people seem to kind of like this example. Think of your RAM, your memory, as a bunch of cubbies. So all these little squares are portions of your RAM that contain data. Let's say I create this object right here. So this is going to be person right here. Well, let me go ahead and go back to that, just like we had it before. So when we do person, what we do when we call change age and name and we pass in person, what's happening is this right here is getting created again. So whereas we have this is our original class object right here, we might be creating another person right here. So we're not this. So this is in our function. This is in our change age and name function. So whatever changes we make in that function is going to be to this guy right here, not our object that we passed in. That's where pointers come into place. So when I created this pointer for person, just like before, what I'm kind of doing is it's not necessarily, okay, so you're creating the space in memory, which is this right here. But you can kind of think of this as like a handle. So this handle holds on to this space. So like it's a, or handle's probably not the right word. Let's say you have a laser pointer. Well, this kind of has a laser pointer to this spot in memory. So it's pointing to this place, nowhere else. So when we take this pointer and we pass it right in to change age and name, we're not actually passing in the object necessarily. We're passing in the pointer. So we're kind of giving this function our laser pointer. That way, whenever we make changes to it, so we're saying, okay, let's increase the age by 5. So what it's doing is it kind of like it's taking that laser pointer, it's pointing to this space in memory, which contains our person object that we created, and it is changing this person's age. It's adding 5 to it. Same thing goes when we add on to the name, like this. So we're pointing to a specific place in memory and changing in that the data in that place of memory. So we're not actually creating duplicates like we were doing when we had it set up like this when we were just passing by copy. So we're actually kind of like having a handle on this object here. So we have like, this is like a space in memory. That's kind of the way I try to look at it instead of an object. So it's a place in memory that you constantly have access to and can change the object inside of that space in memory. And you can pass this, pointer to this space in memory to wherever you want. That's all it's doing is it's just pointing to an address in memory. That's it. So you can access it however you need to. You're only having one object that you're changing. You don't have to create a bunch of copies, because if you have like a very large class, that can be cumbersome and be very wasteful. So that's why you'll find in like game engines, like Unreal Engine, you're like almost everything that you're going to be doing, like any class that you're working with, is going to be a pointer. So any actor, anything like anything like that, that's going to be a pointer. Now, this is quite useful when it comes down to strings. So with strings, if you have a very large string, so like std string, my string equals, let's just say it's that times, I don't know. Let's say you have like a million characters, something absurd in your string for whatever reason. Well, that's going to take up a significant portion of memory. And when you pass that string to another function, like void do something to string, just string. So if I were to do this, do something to string, my string, we just took that giant chunk, like our giant string that's taking up a lot of space in memory, and we now just duplicated it. So we doubled it. So just by simply passing it by a copy to this function, yeah, we're going to have access to everything it has, but we duplicated it. So we're at a heavy cost of memory in this, and just doing it this way. So that's another thing that pointers can kind of help as well. Now that kind of leads me to the next portion, which is pass by reference. So I'm going to go ahead and get rid of the string. And pass by reference, let me actually go back to before we did the pointer, like so. Now pass by reference kind of works in a similar way that a pointer does. So, but it's specific to passing the object. So it's like, how do you hand the object to someone else? You do it in two different ways. You can either give them a copy, or you can give them a pointer, kind of like a pointer to the space where that object exists, so they can make changes directly to your object that you're holding. So we can specify this by using the AND symbol, and that allows us to kind of do the same thing that we just did with a pointer. So just by doing that, if I run it, as you can see, it made the changes, but we're not using a pointer. So when we just do this little tiny symbol here, it changes how we pass it. So we're passing by reference. This is passed by copy. This is passed by reference. When we pass by copy, we're creating a duplicate. So we're modifying the duplicate. So we're not actually receiving the changes down here. When we pass by reference, we are giving them you can kind of think of like we're giving them access to our object space and memory. So it's able to modify it directly. So that's why when I pass by copy, we receive no change. Age is 30, name is Bob. When I pass by reference, age is 35, name is Bob Marley. So it took those changes in. So that's kind of a rough idea of how that works, and that's generally what you would want to do with strings as well. So like I mentioned before with having those giant strings, you're probably going to want to pass them by reference just so that you don't create a copy, because having a pointer to a space in memory is a whole lot cheaper than having a duplicate of an entire object or a giant string. So that's kind of the rundown of that, which leads me to the final thing. When you are done with your pointer, so I'm going to actually go ahead and turn this right back into a pointer. Actually, I really don't need all this. Let's say, I did whatever I wanted to do and I'm done. I don't need person anymore. Maybe I used the class for functionality or whatever. Granted, I would probably use statics for that, but the point being, we don't need person anymore. So just because, when we go and create this object, we're taking up a space in memory, even though we're done with it. So let's say I do this, void create object. And I'll go ahead and just move this in there. So I call create object. Well, we don't, from anywhere down here, we don't have access to it. So I'll just see out, blah, blah. This is all my other code. I'm just continuing on with the program. Well, what I've done is I've taken up space in memory by creating this person object / pointer, and I don't have access to it anymore. Well, I don't have any use for it. It's just going to be sitting there taking up space. So even though I've already gone past this function call, which creates the pointer, I have no use for it, but it's still going to exist. So this is still going to exist regardless. So if I call this like 2 more times, well, we just created person. Just pretend that says person. Yeah, beautiful handwriting. And another one. So we just created 3 places in memory. Well, we're taking up space in memory for an object that we have no access to, no use of. We can essentially discard. That is where you get memory leaks. So with memory leaks, you have just some pointer somewhere that was never cleaned up. So you're just having a bunch of duplicates that it's taking up space in memory and it's just wasting. It's sitting there doing nothing. It's just taking up space like some fat lady on a bus. So you have to make sure you destroy it before, when you have no use for it, you want to destroy it. So like in Unreal Engine, let's say we shoot a character, that character falls, it ragdolls, and it just lays there temporarily. Well, if we had, over the course of 3 hours, if we had 1,000 plus bodies just laying there on the ground, well, that would be quite wasteful. One, we don't need that many for gameplay, and it would be taking up a lot of space in memory because you would be holding a lot of detail in those dead bodies, assuming you didn't just, replace it with a mesh. Let's say it's still the class, well, the actor, you would just be wasting a ton of space in memory. So that's why periodically you would go through and after, let's say, I don't know, every 2 minutes, well, 2 minutes after the character died, you would destroy it. So that way the space in memory got cleaned up and freed for something else to make use of this space. So we do that in C++ by just simply doing delete. So we're going to delete person. So when create object gets called, we create the space in memory. So we create our person, and that takes up the space in memory. We do what we want with it. In our case, we print it out. So I'm going to go ahead and run it. So we print out the info that we need from person. Then we have no use for it, so we delete it. So we're deleting person. So we just get rid of it, free up that space in memory, and then continue on with the rest of our program. Because if we didn't do this, we would have had created, again, what I just called that memory leak, where we would just keep wasting space in memory. So that's of something that has no purpose, that honestly needs to be cleaned up and just taken care of. So that's the purpose of deleting. So you always want to make sure you delete your pointers. Keep track of them, delete them. And I know there's a lot of other fancy stuff. I haven't really gotten into modern C++, but you have smart pointers and all that kind of stuff that really kind of helps you along with it as well. So that would be something else to check out. And honestly, I probably will just so I make a video on it. But that's the basics behind pointers, and how kind of you can think of, well, visualize memory and how it's working. And same goes for how you can make use of passing pointers, passing by copy, and passing by reference, and how you can make use of them whenever you see fit. So a lot of the time, you could save up that little extra space by just passing by reference. Or if it's not really a big deal, doesn't matter, or you might just need a copy. You don't want to actually hold on to the actual object and the address of the actual object. You would just do pass by copy. Or if you really want to, just create it as a pointer and make use of that. Again, it depends on what you're doing and how you plan on using it. So I hope that kind of gave you a rough idea of how to make use of these, because I remember in my CS class, this was the 4th semester. You should have, honestly, I should have known and kind of knew this beforehand, but they didn't really touch much on this hardly at all. And I feel like they should have gone more in depth with it or spent more time on it, because my course was online as well. And it was just 1 week. We had a little bit of homework. The only thing we covered was creating a pointer, deleting it, how to get access to it. So if we really wanted to, we could get the address of it and all that kind of stuff. And it was just by dereferencing and all that kind of stuff. And it was just very basics of, okay, how to use a pointer. It didn't go over what were the benefits of it, where could you make use of it, and that kind of stuff. So hopefully this gave you a little bit of insight on how to make use of it and really just use it in general. Because if you go into something like Unreal Engine, you kind of have to. Like, you don't have there's no getting around pointers if you're going to use C++ in Unreal Engine. And same thing if you're using Blueprint, like behind the scenes, it's dealing with pointers. It's something you're always going to use, like in pretty much every single project that I do, aside from like very basic ones for tutorials. Somewhere I have 1, maybe 10 or more pointers that I'm dealing with, because where I'm making use of them, it makes sense. So hopefully that kind of, well, you know what I'm trying to say. Anyways, It's 4:25, so I'm done for the day. So if you have any questions or anything like that relating to this or any other of my videos, you can find a link to my Discord in the description. I highly recommend you join it. If you have any question the slightest, you'll get usually one-on-one help by me or some other member. If you like what I'm doing and you want to help support me, you can also find a link to my Patreon in the description below, where I have a dedicated Unreal Engine 4 Team Deathmatch series just for my patrons. So, with all that out of the way, I will see you in the next video. Take care.